Marley?
Samples of gases containing nitrogen and oxygen were decomposed by electricity and the volume of each gas produced was measured. Based on these results, which is the correct C.
And number 20. Amari?
Samples of gases containing nitrogen and oxygen were decomposed by electricity, and the volume of each gas produced was measured. Based on the results, which is the correct chemical formula for simple pool? No, C.
20 is D.
Wait, what?
20 is D.
Oh, my bad. I think it's 19.
19 is C. And 21?
I have 100% on this.
21. You make it 21? Now you get points for reading and getting the question correct, and that corresponds to the bell work category. That goes in at the end of the 6 weeks. So you're supposed to have answered 16 things throughout the 6 weeks. Emma, why don't you do number 21?
What is an example of
Alright, so the lab we started on Friday with the separating mixture. So you're going to write the original color, then you're going to write the separated color. If you didn't get a separated color, you just put the original color. And then you're going to do the DF in the next column. That's the distance the solvent traveled, that is the water, how far it traveled, or the alcohol. And then you have the DS, which is the distance the color traveled. So up here, if we're looking at these, this would be the blue. So I draw a line right here, and I'm measuring from the tip of that to the pencil line. Everybody see where we're measuring from? I've got another example right here, and it's showing you the DF, the solvent front, and the DS is where the color stops. This is another example up here. You can come up here and write that down. So we want your data table to show this. And I want you to draw these two solvents on the report as well, because that's the two that we used. And it says here, question number 1, did the experiment separate a mixture? This is what I'm going to check for. I'm going to check for this question and answer. And I'm going to check for number 2, suggest an explanation for using the two different solvents. You're just going to say, we talked yesterday about polarity. So you're going to want to mention something about polarity in number 2. So if I see the word polarity and you're kind of understanding that this is more polar, this is less polar, water's more, ethanol is less polar. You can see the distance. Does everybody see how that could be true? The positive here is farther away from the negative here. So the electrons are going to have to travel a greater distance. So they're not going to be as fast. So it's not going to be as strong a magnet. Make sense? You could say that in number 2. I just kind of helped you there a little bit. That is correct. So she has 1 calcium and 2 fluorine. C is correct. Number 8. Let's go with Laurel.
the chemical formula of a compound indicates D.
D is correct. So I do try to call on those that don't raise their hand as frequently when we go over test questions, because you're more likely to have one of those right. Summer, number 9.
What do chemical symbols and formulas represent respectively? And then I said A.
Very good. So Malachi. All right, let's go with Danny. Number 5. Number 5, can you read it for us?
A train travels at a speed of 30 miles per hour. 1 mile equals 1.6 kilometers. How fast a train travels in kilometers per minute? A.
5 is actually B. Number 6.
Is it 6:30?
Yeah. Florentina?
Number 6, a substance that can be separated into or more substances only by a chemical change is a compound.
So here we have 1 calcium. Yeah, there's 1 calcium, and we have 2 fluorides. 2. So it would be looking like CaF. You need a visual. There's the 2 fluorines there. That's what the 2 tells you. Now the next one is a little bit more difficult, the beryllium hydroxide. So here we have one of the berylliums. The parentheses tells you that you have more than one of the hydroxides. You have 2 of them. So you have 2 oxygens and 2 hydrogens. Everybody see that? So that's a similar pattern you want to follow for the rest of this data sheet. And then on the bottom part, it asks you for lithium. That is, what is the number of protons? And you have 3 protons. The number of neutrons is the atomic mass minus the atomic number. 7 minus 3 is, you'll have to round this a little bit. You'll have to round that number. So if it is not 7, if it's 6.9, round to 7. And then you have how many electrons? Yeah, all elements have what charge? What's the charge on an element? Positive or negative? Raise your hand if you think positive. The charge on an element? Raise your hand if you think negative. Florentina? Yeah, it's neutral. Because you have 3 positives and 3 negatives, so it has to be neutral. So all elements have 0 charge. The atomic mass is 7, and the atomic number is 3. Now the atomic number is very important. What does it tell us? Yeah, what does that tell us? It tells us the look. Looks matter. I know y'all don't think looks matter, but y'all dress up and change your appearance. Just be careful that you don't have too much plastic surgery, because I've seen some people that it starts affecting their behavior because they really mess it up pretty bad. Yeah, because they think looks are just so important, which they are. I mean, the atomic number is pretty significant. Now, we want to figure out how to make gold more, I guess you would say, abundant, and the atomic numbers associated with that. We have not figured out how to do that yet. If you're looking at the particle accelerators that we have built, that would be the fundamental goal, is to make elements that are very useful. Specifically, gold and platinum have enormous use because they're fairly non-reactive. But if you have too much of it, I guess it would be bad, because then everybody would just have gold everything. Yeah. Well, the biggest drawback with gold, it's very dense. That means it's going to be fairly, you can't put a lot of it on a truck, because you can't put the same amount of gold that you put, let's say, water on a truck, so transportation issues are going to be a problem. If you have everything in gold, just saying. So be aware of that. Data table on it. And we're going to start with the original color. So the original color in this example was green. You can see the green right there. So you'd write green. Now the green separated into 2 colors. You can see here it's separated into the yellow and the blue. So you'd have a separate color, yellow, blue. Now the DF is the distance the solvent traveled, as you see right here. That would be the water. So in this case, the water traveled the same distance as the blue. So the DS is going to be the same as the DF. Let's say it's 6 centimeters, 6 centimeters for the blue. Now the yellow, everybody see the yellow didn't travel as far as the blue did. So you're going to have a separate measurement for the yellow. That would be, you're going to have a separate DS for the yellow, because the DS is the color. Now up here I've got this labeled on this graph right here, or this table or paper. The DS is associated with the color. So I have a DS for the blue, I have a DS for the green, right? And then you're going to calculate the RF. So the RF equals the DS divided by the DF. And these 2 questions I want to answer. Did the experiment separate a mixture? You're going to say yes or no, explain. The second question suggests an explanation for using the two different solvents. You need to draw both of these solvents on your lab paper. Now, yesterday we talked about water, and what is the characteristic of water? It starts with a P. It's magnetic. Yeah, it's polar. So water is very polar, high polarity. What about ethanol? What's its polarity? It's lower. It is polar. Yes, how do we know that ethanol is polar? It dissolves in water. Now, one day, you will be old enough, like when you're 21, to go to, let's say, an alcoholic beverage store, and you could look at, let's say, vodka in a glass or gin in a glass container, and when you turn it, you're going to notice it's not very sticky to the glass compared to water. So water is much more polar or sticky compared to the alcohol. Is that right, Claire? Now be careful with alcohol because there have been some accidents just recently. There's a guy at UK who ran over some 4-year-old, and then there was a principal was driving down the wrong side of the road with alcohol. They were drunk. So alcohol is a depressant. It will put you to sleep. So if you're having sleep troubles, you can use something else called tryptophan. Where would you find tryptophan? In Turkey. So there are sleep agents that can be other besides alcohol. Just be aware that if you drink it at nighttime, it's very difficult to stay awake. Yes, Sydney?
Oh yeah. On like the whole like the 4-year-old thing, I was like listening to the news this morning about it. And they were like, he had like 2 beers and like you really couldn't get that drunk off 2 beers to run over a little 4-year-old.
Right. He's just admitting guilt. He's just trying to admit some guilt.
But I just like
And number 3. Go with Summer. And number 4, how about Samara? And number 5, by Joanna. That is correct. And 6, Daniel.
6.
Yeah. I try to at least call on you once.
A substance that can be separated into 2 or more substances only by a chemical chain is a
47, they're saying, is C. And 48. All right, Jamilian. And 49. Let's go with Naja. And last one. Let's go with Emma.
A 76.0 gram sample of an unknown compound contains 12.90 grams of sulfur. What is the percentage by mass of sulfur in the compound? I said B.
What is it?
1634.
1. Lab students are working on today. So homework tonight, and students yesterday demonstrated this third law with the automobiles crashing into each other. Right, so the proper bell work is this. I had a student distract me earlier when I was writing that.